All right, so for this, what I want you guys to notice is that we are going to be dealing with neutralization, okay? So when you're dealing with your titrations, you tend to be doing neutralization. Okay? I know for sure if you had me last year, we set up a titration. I don't think we all did it, but we at least set it up and we did like a swirly swirl or something like that. I'm not sure about over there. So, but for your neutralization, what it comes down to is you're going to have like kind of a curve showing your pH and the concentration, and you're going to be looking for a point that's kind of straight up and down, and that's going to be your equivalence point. Okay? As long as you're dealing with a strong acid and a strong base, that equivalence point is when you are neutral. Okay? When you have a weak one and all that stuff, things change up a little bit for our titrations, but we're not going to deal with that till we get to equilibrium. But when you have a strong acid and a strong base, you're always going to be making what two products? Water is one of them, and a salt. Okay? And please remember, your strong acids have that extra proton. Your strong bases have that hydroxide. Okay? Okay, so at this little equivalence point, okay, your moles of your acid will be equal to your moles of your base. Okay? And so I want you to be prepared for when you see this on your online homework. There's two different ways that you solve these. And it depends on what you have going on in your chemical reaction. Okay? If you have a 1-to-1 ratio, and only if you have a 1-to-1 ratio, you can use MAVA equals MBVB, okay? Which looks like M1V1 equals M2V2, right? It is. That's exactly what it is. And as long as you have a 1-to-1 ratio, you just plug and chug into that, and you're good to go, okay? However, you do not always have a 1-to-1 ratio, okay? So the other way to do it is you're going to have to do something that kind of looks like stoic to a mole ratio. And once you have that, then you're going to continue on to this little MAVA, MBVB, okay? So any other kind of ratio, you're going to use this, okay? Typically what I like to tell my students is just use this one, because then you can always, you'll never forget it, okay? But I do have a lot of students in the past who really rely on this, especially for your multiple choice when you're just trying to do a quick plug and chug in your head. It's obviously going to be easier. So, all right, so I'm going to just show you one of each, and then we're stopping, okay? So the first one for 12A, I have us calculating the molarity of hydrochloric acid in a 20 milliliter sample, which is neutralized by 18.5 milliliters of that sodium hydroxide stuff. Okay, so hydrochloric acid we know is HCl. Okay, we're going to neutralize it with some sodium hydroxide. And that's going to make what two products? Good. NaCl plus H2O. Do I need to worry about balancing anything in this? No. Okay. Let's go ahead and write the amounts that we have underneath it. So we have 20.00 milliliters. This one we have 18.50 milliliters. This one we have 0.750 molarity. And this we want to know the molarity. Okay? So this is where you look at how these guys are related. If you notice, what type of ratio do we have right here? Between HCl and NaOH. It's a 1-to-1, yeah. So since it's a 1-to-1 ratio, we can go ahead and plug and chug into our MAVA MBVB thing, okay? So, sorry. Okay, make sure things are in liters, and then you're going to solve for your molarity, okay? So feel free to work ahead, kind of get yours if you know what you're doing. Okay, and so what this sets you up for is you're just solving for your molarity of your acid, okay? And the only reason this works is because it's a 1-to-1 ratio, all right? So we're basically saying when the moles of HCl equal the moles of sodium hydroxide, we have now neutralized our situation, okay? So when we do all this, we get our molarity of your acid to be what? Don't look at me, I don't have a calculator, you do it. You're looking at me. Type it. Yes. Sorry, no. We earlier we rounded because we did it in steps. So yes, you're right. Okay, so 0 point, and we're gonna go to 3 sig figs, right? Yeah. So 694? Yes, ma'am. Okay. Sounds good. Okay. Just take it. It's okay. Okay. All right, so do we see how that kind of worked out? You didn't have to do too much, okay? Now I'm going to run you through the other process, and hopefully you'll see that it's really not too much different. What you did, just so you know, okay, was when you did this little part over here, you've solved for moles of B. Then what you did was you said moles of B was equal to your moles of A, and you put it over the volume to figure out molarity, right? That's really all that you did, okay? It's kind of in disguise there. So that's all that, we're gonna follow that same process now for when we don't have a 1-to-1 ratio. So this one is saying calculate the molarity of sulfuric acid in a 20 milliliter sample, blah, 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 it's all the same stuff. All right, so we have sulfuric acid. What is the formula for sulfuric acid? H2SO4. There we go, H2SO4. We're going to add it to some sodium hydroxide. We're going to make some, what's my salt this time? Good. So sodium sulfate plus some water. Are we balanced this time? No. All right, just to save you time, you're going to put a 2 by the water and you're going to put a 2 by your sodium hydroxide. Okay? So now, what just happened? What did I change my ratio to now? A 1-to-2. This right here tells you I cannot use MAVA and BVB, okay? So we need to change that. All right. Okay, so when you see that it's not a 1-to-1 ratio, oh, wait, let's go ahead and write this in real quick there. Don't forget your sig figs. I'm not going to keep up with my sig figs, just writing this stuff down. But we're still going to be using this information. But what we're going to do now is we're going to slow down. We're going to solve for my moles of B, okay? So moles of B we can get from this information, right? Because we know that molarity is moles over volume, okay? We have 0.750 is equal to moles over 0.0185. So go ahead and type that in, okay? You're multiplying to solve for moles of B. Once you got it, go ahead and shout it out. We'll get a second on it. We're going to go to 3 sig figs on this one. Yep. Okay. So 0.0139 moles of the base. Okay. So now we want to know, okay, but how many moles of acid does that make? So what we've got is we're going to start with our, there you go, 0.0139 moles of, I'm just going to put B again. Sorry. I'm going to put moles B down here. We want to relate it to our moles of our acid. What is the molar ratio between those two? It's a 2 to 1. So we're going to put the 2 down here, the 1 up here. That's going to tell me that I now have I'm going to save you guys some time. 0.00695, right? Because it was 4 something. Okay.
37. 69. 37. So 69. Yeah.
Okay. All right. So moles of A. What can I do with that information now? I want to know molarity.
Oh.
Who do I put that over? By the 20 mils, right? Because you guys see that that's how much we have. So if that's the amount of moles inside that 20 milliliters, we need to know what the molarity is. All right, so you're going to divide it by the 0.020 liters. And you should end up with, mine is probably going to be off, but 348 molar. Yeah? Sweet. All right. Okay, so that is some titration business in a nutshell. Okay, I want you, like I said, I want you to have that so that when you start approaching this next homework assignment, you can kind of at least have that next to you to start with on your titration stuff. Okay, cool. All right, so go ahead now, put that somewhere safe. What's up?
What is that work for you?
Right now it says it's on Wednesday, right? It's not going to be Wednesday. It's going to be Friday or probably this weekend again. Okay, I have to lay out my life, right? Figure out your guys' days now. My whole schedule keeps changing. I love it. So I will let you know, but it's open already. Okay. All right. So go ahead and make sure that goes somewhere safe. Like I said, I do recommend you start keeping a binder in here, and that way you keep all your notes in one location, your references in one location, and all that good stuff. Okay. So this is the rest of your Unit 2 stuff. All right. We're going to take a look at that bullet lab. You guys should have a lot of time now to kind of get your stuff done. But you should have been able to do 1 through 3 without me. Okay? 1 through 3, you didn't need any data from here. You just needed to do some calculations. Number 1, you might have to do a little bit of research, or you could come talk to me about it. Okay? Number 2, I told you I wanted you to graph it, and then you're finding your slope of a best fit line again. Number 3, okay, what equation am I asking you to use in number 3? You're supposed to be preparing yourself for dilutions. What's the dilution formula? Yes, M1V1 equals M2V2, okay? So, a couple things here. V2 is always going to be 0.010 liters. Because I tell you right here, I want you to make 10 milliliters of each one. Okay? Okay, your M2, you are deciding as a group. If you already did it, then you're good. You don't have to worry about changing it, okay? Decide as a group. So if you choose to do this right now, you guys are going to do that. I basically say I want 4 different dilutions anywhere between 0.4 and 0.025. Okay? That always bothers people because they're like, freedom, what do I do with it? Ah! But seriously, just do it. Okay? So you can do 0.05, and then you could go 0.1, 0.2, 0.3. See how easy that was? Not too bad, right? Except I know I struggled on the first one. All right. And then volume, this is who you are solving for. This, you're going to put 0.4 for all of them. Because I'm handing you 0.4 molar solution, and you're creating your dilutions from this. okay? I have more. This isn't all I have, I promise. This wouldn't be enough, okay? All right, the other one that I'm going to prepare you guys for, you guys have enough time to do it, is you can kind of see, do you see their bullets over there in the fume hood? Yeah? You guys are going to break into your groups today. You will get a bullet. You will write down your little observations about your bullet. You're going to get a mass of your bullet, and you get to name your bullet, and you're going to put it on a sticky note and wish him farewell because tomorrow he's going to die. So, all right, I'm but seriously, you guys are going to do that, and then you should be actually able to do number 4. Number 4 is very similar to what we did as a warm-up one day, okay? You're going to have your information about copper. You're relate it to this guy, get it in moles, and then you need to solve for how much you need in order to dissolve it with that molarity, okay? So you guys will be able to do it. You do need to try it. And then I will put a help video up on about number 4 tonight, okay? I don't mind doing that, okay? Are we all clear? We're good? Please don't forget that on the other side it also says you had to come up with a purpose. This one I did not provide a purpose to you, so make sure you know what your purpose is, okay? If you're struggling with that, talk to me. Do you guys have any questions for me? No? Okay, all right.